from here to here is 2I plus 2 theta, and then from here to here is 2I. I'm now going to subtract it, which means that x degree is equal to 2I plus 2 theta minus 2I. So this 2I, we take away this 2I, it gives us what?
2 theta.
So we have to, in other words, the change that is made by the initial reflected ray and the final reflected ray is going to be twice of the angle that was made here. Does that make sense?
No.
My name is Joseph Precious. In case you were wondering what happened in the previous video with my class student, I was trying to explain the effect of a turning mirror with a fixed light source. And don't try to be confused about this, it's quite a small thing. So we happen to have a mirror whose position is AB, and as it changes, remember the light source is fixed and has made what we call the incident ray. So the mirror is changing from AB to what we call the AB prime, happen to be the new position of the mirror now, and the angle that has been made with AB prime with AB itself is called theta. So we also have what we call normal to the plane mirror. This normal to the plane mirror is meant to be 90 degrees from the mirror plane or from the mirror surface. It tries to show the direction to which the mirror is facing. We call it normal to the plane mirror. So as the mirror changes from AB to AB prime, the same thing happens for the normal to the plane from N to N prime. In other words, it makes the same magnitude of angle of which the AB prime makes with AB with its initial and final point. So let's recap again. You should know that the normal to the plane mirror indicates the direction to which the plane mirror faces and is always at 90 degrees. It shouldn't be less or greater than that. So that is why the changes along with the mirror was made with the normal to the plane mirror. So now that we have here to be theta and we have here to be theta as well, with a fixed light source, the reflected ray happens to be changing from R to R prime, and then the angle made with the initial position of reflected ray and the final position of the reflected ray is X angle or X degree. So we are going to find out what the value of X degree is. So let's take, for instance, this is the initial position of the mirror AB with a fixed point O. So as we have the incident ray, we also should know that the angle of incidence is equal to the angle of reflection. That is the second law of reflection as a property of wave. So now we have angle of incidence is equal to angle of reflection. We will be using that interchangeably. As the changes are made, remember that the N prime now has also made a change along with the changing mirror, which happened to have added extra theta. In other words, the same thing happens for here. Since angle of incidence is equal to angle of reflection, we should know that the changes was added. The same thing goes here. And then if we wanted to find out the angle between the incident ray and the final reflected ray, we will be adding theta I plus theta I plus theta. In other words, that will be giving you 2 theta I plus 2 theta. So going back to this. This being said, how do we now find the angle X degree? Remember, the angle from here to here happens to be 2 theta I plus 2 theta. So we now want to find out what the angle between here and, here would be. So how do we do that? Remember that the angle from here to here is theta I plus theta. Observe carefully. And now, that being said, what is going to be the angle here? Since we have theta I plus theta here, that means the angle here must have reduced. The angle, this was supposed to be the reflected ray, the angle of reflection when the mirror was in its initial position. But since this has come here, the angle here, we want to know the angle here. The angle here has reduced by theta. In other words, we have here theta I, or you can say theta R minus theta, which is the decrease due to the change of the normal from its initial position to the final position. Don't be lost. So the angle here is theta I minus theta, while the angle here happens to be theta I plus theta. In other words, adding all of this together would mean theta I plus theta I minus theta. So negative theta will take out the positive theta, and then we have here 2 theta I. So finding out what this means would mean finding the total angle from I to the final reflected ray, and then subtracting it from the angle between I and the initial reflected ray. So with respect to the changes of n. So that would mean x in its degree would be 2 theta I plus 2 theta minus 2 theta I. So which would become negative theta I would take away the 2 theta I, and then x is equal to 2 theta. In other words, the changes made by the reflected ray with respect to the changing mirror position, the final reflected ray to its or with its initial reflected ray happens to be 2 theta. In other words, twice the angle that was made here. So, see you later. Bye.